Hi, I'm RL from MathinSG.com. So in this video here, I'll be going through the 2024 H2A Level Math Paper 1, Question 6. The work solution can be found in this website here. I'll provide the link in the description below. So now let's go through this question here. So this question is an application of differentiation and integration question. So we are given a curve which has an equation y equals to 2e to the power of x cubed plus a, where a is a positive constant. The point T lies on C and has an x coordinate of 1. So use the calculus, so that means you cannot use your calculator, to find the equation of the tangent to C at point T. Give the equation in this form where P, Q, and R are exact coordinates to be determined. So let's take a look at this. So we are given this one here. Okay, and you want to find the equation of a tangent. So in order to find the equation of a tangent, which is a straight line, right, we need the gradient, which is m, as well as a coordinates, which includes both the x and the y, so that once we know this, we can find the equation of the tangent, which is taken by this formula y minus y naught equals to mx minus x naught. So now we know that the x coordinate is 1. We need to find the corresponding gradient of the tangent at x equals to 1, as well as what is y naught. Okay, so to find y naught, we will sub in x equals to 1 into the equation of the curve. Okay, so we have found this y naught. Okay, next we need to find the gradient of the tangent, right? So to find gradient of tangent, we will first find dy dx, and recall that when we differentiate e to the power of fx, you will get f prime x e to the power of fx, where f prime x is the differentiation of fx. So I need going to differentiate x cubed, so which give me e 3x squared. So 2 times 3x squared e to the power of x cubed. Then differentiate a, which is a constant, will give me 0. So I'll get 6x squared e to the power of x cubed. So when x is equals to 1, I have my dy dx equals to 6e. Okay, so now that I have the gradient as well as the y coordinates, and I already know that the x coordinates is 1, I can find the equation of tangent. So y minus y naught is equals to a, which is, m, which is 6e, my gradient, x minus 1. Okay, so I'll bring everything over. So I have 6ex minus 6e plus 2e plus a. And I know that I need to write it in this form here. So everything with e must be factorized together. So I have y equals to factorize e out. 6x minus 6e plus 2e is minus 4e, and I factorize e out, so here is 4 minus 4 plus a. So comparing this portion with here, I know that my p is 6, my q is minus 4, and my r is 1. Okay, so that's for part A. Moving on, is given that the tangent to C at T passes through the origin. So if we know that it passes through the origin, we can sub in x equals to 0, y equals to 0, right? Okay, then it will satisfy the equation of the tangent. Or if you have to take a look at it, okay, you have y equals to e6x minus 4e plus a. So if the line passes through the origin, then y equals to mx plus c, which is the y intercept, must be equals to 0, and this is our c, right? So minus 4e plus a must be equals to 0, so a is equals to 4e. All right, next let's do part B, part 2. You're asked, find the area of the region bound by C, the line x equals to 0, and the tangent at T. Give your answer correct to 1 decimal place. So I see this, I know can use GC to integrate. Okay, you don't need to integrate it yourself. Okay, so you just need to find out what you want to integrate. Type it into your GC, get the answer corrected to 1 decimal place. Do not do the integration yourself, because it said so. 1 dp means use GC. Okay, or estimate or round off, as long as it's not exact value and the question doesn't say do not use GC, use GC. Okay, now coming back to this, we know that we are interested to find the region bound by this curve, then the line x equals to 0 and the tangent at t. So use your GC first to do a sketch. Okay, this is what we get. So this is our equation of the tangent, right? Which is y equals to, what's the tangent here? 6ex. Okay, 6ex. And I know that there is no c or no y-intercept because the tangent passes through the origin is given in part B already. So I know this is y equals to 6ex. And this is the equation of the curve y equals to 2e to the power of x cubed plus 4e, because the a we have found in part B1 is 4e. Okay, so now I'm interested in the area bounded by the curve C, which is this blue curve here, x equals to 0, which is this y-axis here, and the tangent at t, this is the tangent. So basically, which here is 1, right? So I know that this is the area I want. So how do I find this area? So there is no intersection in between 0 to 1, it's just from here, right? So basically what we know is we need to integrate top, which is this curve, minus bottom from 0 to 1. Okay, so 0 to 1, curve is this one, right? 2ex cubed plus 4e dx minus the bottom, which is this line here, or you can just find area of the triangle if you want to, but since I'm going to use the GC, I'll just type it in, so it doesn't matter. So 6ex dx. Okay, then don't do the integration yourself, type it into your GC, all right? And you will get 5.4 units square when rounded off to 1 dp. Okay, this one is GC, okay, because of the words here. Okay,